Hey, honors physics students, how about some hints about the chapter 14 and 15 textbook assignment? Not all the problems, but a few of them. Let's look at number 76 in chapter 14 first. It has to do with ocean waves, and so I would recommend that you use the formula velocity equals frequency times wavelength, which works for all waves, certainly ocean waves. However, one thing you need to watch for is if they give you the time, that's not the same as the frequency. The frequency is the reciprocal of the time. Time is the number of seconds per wave, so the frequency would be the number of waves per second. So that'll help you get started on that one. Number 78 is the next one. Again, it's water waves. And again, you recognize that we could use velocity equals frequency times wavelength. However, what about the velocity? They don't give you the velocity, they give you the distance and the time. So remember, for all waves, because they go a constant velocity, you can use velocity equals distance divided by time. Then certainly velocity equals frequency times wavelength would be available to you on number 78. Then looking at, for instance, number 81. The most important hint I'm going to give you about this one is that the time down and back is not what you want. The time down and back is twice what you want. Okay, so if you want to use velocity equals distance divided by time, you certainly don't want the time down and back because you want to find the distance just down. So that'll be a little something you can fix. And then one more to look at here. How about number 100? Okay, so number 100 has its own formula for the velocity of a wave on a string, like a guitar string. Well, a couple of notes here. So we like to have, since Newton is a part of the formula, we want meters for any distances and kilograms for the mass. That'll be an easy conversion for you. So I would suggest starting with velocity equals frequency times wavelength. And the reason for that is velocity is part of the formula you're going to use that you see on problem number 100. Then the next thing you need is mu is not the coefficient of friction in this case, it's the mass divided by the length, the mass per unit length. And so when you're finished with that, it'll be relatively easy algebra to solve for F sub t, the force of tension. Now let's switch over to chapter 15 and begin. There aren't very many questions on chapter 15, and certainly I'll have lots of worksheet questions for you, but let's look at number 54 to start with on chapter 15. Number 54 is asking about also sound waves like you've used before. And so simply use velocity equals frequency times wavelength like we did in chapter 14. Let's get that back where you can see it. My apologies. Okay, now let's look at number 57. Okay, number 57 seems to not have enough information because you have the sound frequency, you have the temperature. It seems like, what do you do with the temperature? However, here's a hint. As you probably read on page 495, and that can't be right. It must be 395. Let me look at that again. If you look back in the chapter at one of the first pages, that would be 405. So on page 405, you're going to find a chart that will help you find the velocity. That'll help you start out number 57. Let's look at number 66. Okay, number 66 is the last one I'd like to give you a hint about. All right. First of all, on number 66, use velocity equals distance divided by time. It's like that other problem that we recently did. However, you only want the one-way time, not two-way like they give you. Well, of course, how does that help you deal with the mud? So, tiny hint. Once you use this formula, remember, for the mud, you might want to use some subtracting. That's the only hint I'm going to give you on that one. I hope it helps. Have a great day.